Okay, so let's continue on working some of these problems. 3x minus 12 over 2 equals 9. Notice that the order in which this left side is done is the multiplication is done first, then the subtraction, and then the whole thing's divided by 2. So in order to unwrap the left-hand side, we need to go in reverse order, which means we do the 2 first, then we get rid of the 12, then we get rid of the 3. So how do we get rid of this 2? Well, the whole thing's being divided by 2, so I'm going to multiply both sides by 2, and that'll get rid of that. That'll leave me with 3x minus 12 is equal to 9 times 2, and 9 times 2 is 18. I multiply both sides by 2. On the left-hand side, the 2 has 2 divided by 2 is 1, so it just disappears. I'm left with the top equals 18. The next thing I'm going to do is get rid of this 12, because that's kind of the next thing before the 3. It's kind of the next in line. I've got a minus 12, so I'm going to add 12 to both sides. That's going to leave me with 3x equals 18 plus 12, which is 30. Now again, I've added 12 to both sides, but on the left it's dropped out because minus 12 plus 12 is 0. So I'm left with the 3x. The final thing to do is get rid of this 3, and the way to do that is divide both sides by 3 because this is multiplied together, so I'm going to go ahead and divide by 3. That's going to give me x is equal to 30 divided by 3, which is simply equal to 10. And that is the answer. And if you were to take 10 and put it right back in there, you will see that that is the one and only value of x that will actually satisfy that equation. Let's do one similar. 5k minus 8 over all over 9 equal 1. You don't want to start with the 5 or the 8 as far as isolating because the way in which you kind of unwrap the left-hand side is the opposite in which it's formed. And if you were to plug this in your calculator, you would take 5 times k, and then you would take that answer into minus 8, and then you would take that answer and then divide the whole thing by 9. So you need to work in reverse order in order to isolate k. So you get rid of the 9, then you get rid of the 8, then you get rid of the 5. So we're going to get rid of the 9 by multiplying both sides by 9. So we've got 5k minus 8 is equal to 1 times 9, which is simply equal to 9. Now I'm going to get rid of this 8. I'm going to do that by adding 8 to both sides. That's going to leave me with 5k, 8's going to go away, equals 9 plus 8, which is 17. And then in order to get rid of this 5, it's being multiplied by k, I'm going to divide both sides by 5. So k, 5 is going to drop away, is equal to 17 over 5. That's the answer. I know it doesn't look pretty, it's a weird looking improper fraction, but that is the answer. And I'm hoping that we're going to work so many of these problems that it's going to become second nature to you. After a while, you don't even have to think about what to do first, second, or third. It just kind of comes to you. Alright, this is kind of a neat one. Let's try 3z plus 2 divided by 17 is equal to 0. Now this is going to be fun. Watch this. Let's get rid of the 17. I'm going to multiply both sides by 17, so that's going to leave me with 3z plus 2 is equal to 0 times 17. 0 times 17 is simply equal to 0. Next, I'm going to get rid of this 2. I can't get rid of the 3 because if I were to just divide everything by 3, that wouldn't really cancel in the way that I'm wanting it to cancel to drop out that 3. So I need to work in order. The next thing I need to do is this 2. I'm going to get rid of this 2. I'm going to subtract 2 from both sides. So I'm going to be left with 3z. 2 is going to disappear on the left, equals 0 minus 2. And of course, by definition, 0 minus 2 is negative 2. Finally, I'm going to isolate the z, get rid of this 3, so I'm going to divide by 3. Z is equal to negative 2 divided by 3. And that's simply a fraction. That is the answer, negative 2/3. And if you take negative 2/3, plug it into z, you will find out that, in fact, if you do that, 3 times negative 2/3, the 3's are going to go away. You're going to be left with negative 2 up here. Negative 2 plus 2 is 0. 0 divided by anything is 0. and that's why the right-hand side is 0. If you plug any other value of z into that equation, you will get, I guarantee you, something other than 0. There's only one and only one solution to that equation. Let's say we have, getting a little bit more complicated, 17k minus 28 over 21 plus 4/3 equals 0. Now again, the goal is to isolate this guy. So, you've got 17 times k, then you subtract 28, then you divide by 21, then you add 4/3. So we need to go in reverse order. So in reverse order, 4/3 is going to be the first to go. The way I get rid of that is subtracting both sides by 4/3. I'm doing the opposite. It's being added here, so I'm just going to subtract it. So I'm going to be left with 17k minus 28 over 21 equals 0 minus 4/3, which is negative 4/3. Now, the 4/3 has disappeared from the left because I've subtracted 4/3 from both sides. Okay. Next, let's say that I'm going to multiply both sides by 21, because now I'm going to try to get rid of this 21. So I'm going to get rid of this 21 by multiplying both sides by 21. 17k, I'm going to be left with 17k minus 28. 21 is going to drop out once I do this multiplication, equals minus 4/3 times 21. Now notice on the right hand side I've got 4 times 21 over 3. You can almost think of this 21 as 21 over 1. 21 divided by, let me do it this way. I can divide 3 into both of these things. 3 divided by 3 is 1. 27 divided by 3 is 7. So really I've reduced this fraction to 4 over 1 times 7 over 1. So I'm going to be left with negative, because I've got a negative out here. 7 times 4, 28 on the right hand side. Now looky here. I've got a 28 here and a 28 here. Next thing I'm going to do to get k closer and closer to being isolated is I'm going to get rid of this 28. That's going to leave me with a 17k. I'm adding 28 to both sides. 28 disappears here. Minus 28 on the right plus 28, which is simply equal to 0. Negative plus positive of the same number always gives you 0. And then, in order to finally get k by itself, I'm going to divide by 17, because I've got a multiplication going on here. K is equal to 0 over 17, and that is always going to be equal to a big fat 0. So after all that work, you're left with 0. First, we moved the 4/3 to the right by subtracting. Got a negative 4/3. Then we moved this 21 over there by multiplying by 21. We reduced this fraction, and that was actually equal to 28. Then I took the 28 over by adding it, which made the right-hand side equal to 0. And then we divide by 17, which, since you're dividing it by 0 by 17, it always equals 0. Okay. Just a few more problems. Actually, there's one more problem. 2 more problems maybe. Let's try something like negative x over 3 minus 1/2 equals negative 5/2. Again, the order in which this were to occur, should you actually multiply it in your calculator, you take x divided by 3, you get a number. Then you subtract 1/2, and that would be equal to something. So in order to get x by itself, I'm going to do this all in reverse order. I'm going to first add 1/2. That's going to leave me with negative x over 3 on the left. The 1/2 is going to go away because I'm going to add a 1/2 here, and that's going to make this equal to 0. So this is going to equal to minus 5/2 plus 1/2. I add 1/2 to both sides. This is going to be equal to negative 4/2, and you can prove that to yourself by, you keep the 2 because the 2 is the same on the denominator, and then on the top you basically got a minus 5 plus 1, and you can go back to the other part of the course and convince yourself that's a negative 4. And further, you can convince yourself that negative 4 over 2 is simply equal to negative 2. You do the division, and then because you got a negative over positive, you just make it negative. So what I'm left with is negative x over 3 is equal to negative 2. In order to get x by itself, or closer to being by itself, I'm going to multiply both sides by 3. So I'm going to be left with negative x is equal to negative 2 times 3, which is negative 6. Now here's the funny part. I've got negative x is equal to negative 6, which is great. But in order to get x by itself, you can kind of understand this to be, instead of simply negative x, it's like negative 1 times x. So I'm going to divide both sides by negative 1. So x is really equal to negative 6 divided by negative 1. And negative 6 divided by negative 1 is positive 6. So x is equal to positive 6. And you can go back to the other parts of the course and convince yourself of that fact by looking at fractions and how you divide numbers by each other with different signs. It's not that bad. Now here's the final problem in this section. So here it is. 9 minus 5w divided by 15 is equal to 2/5. I want to solve for w. Because of the order, 5 times w, then you've got this subtraction going on, then you've got the whole thing divided by 15. I'm going to get rid of the 15 first. I'm going to multiply both sides by 15. That's going to leave me with 9 minus 5w is equal to 2 over 5 times 15. I've multiplied both sides by 15. Now the cute thing here on the right is that I can simplify this, because this is kind of like 15 over 1. I can divide both of these two numbers by 5. 5 divided by 5 is 1. 15 divided by 5 is 3. So I've reduced the right hand side to 2 over 1 times 3 over 1, which is simply 2 times 3 is 6 over 1, which is obviously 6. So this whole right hand side equals 6. That is true. So the next thing I want to do is, I'm left with 9 minus 5w equals 6. I want to get 5w by itself, so I'm going to get rid of this 9. And so this is a positive 9. The only way I can get rid of it is by subtracting 9. So I'm going to be left with, after I do that, 5w, negative 5w, equals 6 minus 9. I've subtracted 9 from both sides. The 9 dropped out here. I've got my 6 minus 9 here. So this is what I have here. 6 minus 9 is equal to negative 3. You can see that because you've got the bigger number is negative, so the sign is going to be negative, and then 9 minus 6 is 3. So that's why that is the case. Now the final thing is, in order to get w by itself, I'm going to divide both sides by negative 5. And that'll leave me with w equals negative 3 over negative 5. Negative over negative is a positive. So I'm just going to be left with positive 3/5. These positives go away, but the numbers stay the same because you can't actually divide 5 into 3. So here we've solved a few different kinds of equations. They're a little bit more complicated, but not crazily complicated. You just have to look at the order in which things are multiplied together and then start doing things in reverse order until you isolate the variable. And you just do the opposite, keep track of the signs, get very comfortable with multiplying and adding and subtracting negative numbers, and then you'll be good to go.